today we'll take a look at graphing by point plotting. To represent the location of a thing in two-dimensional space, we use something called a Cartesian plane. We set a center called the origin, and we look from that center in two different directions. The horizontal direction we label an x-axis, with the right being positive, and a y-axis vertically, with the up being positive. When we intersect those two perpendicular axes, that divides the plane into four quadrants. Starting on the top right, we label that quadrant 1, where both x and y are positive, and then moving counterclockwise, the top left is quadrant 2, the bottom left is quadrant 3, the bottom right is quadrant 4. We can describe any location on this plane by using a coordinate pair. So we choose the points x, y, we write them in parentheses with a comma between them to sort of separate the two coordinates. We use x, the first number written, to represent the horizontal distance away from the origin, that's center point 0, 0. And we use the y coordinate to represent the second number there, to represent the distance above the origin. And so putting those two amounts together, you can write any amounts in there, x, y, and that will give you a unique point on the plane. In order to graph a function, such as a line, essentially a function is just infinitely many coordinate pairs combined together that follow some sort of rule. So we identify what that rule is. We can plot several points, several coordinate pairs that fit that rule, and then connect them using the pattern that we can identify based on the type of function that we're looking at. So for example, this is a linear function. The function f of x equals 2x minus 1. F of x is function notation that essentially means the same thing as the y coordinate. So all we need to do is set up a few x values of our choice. Think of those as the inputs. It's pretty common to choose -2, -1, 0, 1, 2, at least to start with. But depending on the function, you may want to choose different x's to find easier values to make your sketch. But essentially, pick a series of x values, plug them into the function itself, right? So we'll take that -2, -1, 0, 1, 2, substitute each of those in for x individually. You can see those here, right? So we'll take -2, -1, 0, 1, 2, plug those numbers in. That's been done in this table for you, right? So multiply each of those numbers by 2, subtract 1, and you'll get an output, or a y value. Putting those two numbers together, for example, -2 going along with -5 makes the coordinate pair -2, -5. And we can plot that point on the coordinate plane just by going from the origin, going left 2, and then going down 5, since the 5 is negative. And that locates our first point. We can repeat that process, in this case, 4 more times. And you'll see those other 4 points corresponding as well. Since we know that's a linear function, and since it looks like those points are equidistant, we can connect them and sketch out our line from there. So let's try one more. Suppose we have this function, f of x equals the square root of x. Think about what you think that graph might look like. Think about what it might look like to substitute in different values of x there into this function and see what the output or the y values are. I added a few extra ones here. You can start with -2 to 2 if you'd like. 0, 1, and 2 work perfectly fine. The square root of 0 is 0, the square root of 1 is 1. The square root of 2 is an irrational number, which exists. It's about 1.414, but it's not a nice pretty one, right? So that one, we'll sketch that one, but it's a little bit harder to locate. Notice -1 and -2 didn't work so well because those numbers are undefined, right? The square root of -1 and the square root of -2 are not real numbers, so we can't graph them on this plane. They don't exist here. So I said those 2 points were undefined. We won't plot anything for those. So I added a few more since we only had 3, right? Continuing on, we know the numbers whose square roots come out evenly. Those are the perfect square numbers, right? So 2, 4, 9 would work. So if the square root of 4 becomes 2, the square root of 9 becomes 3. Lastly, I picked 16 as well because the square root of 16 becomes 4. Creating those coordinate pairs, 0, 0, 1, 1, 2, square root 2, which we'll sketch again, but that's harder to locate. 4, 2, 9, 3, 16, 4. We can plot all of those points and we'll achieve a shape that looks something like this. So notice these points are not equidistant from each other, and that's okay, but we can see that there's a sort of flattening pattern. It does continue out high. It doesn't level off at a certain amount, but the slope, you could say, between any of these 2 points is getting smaller and smaller. So these points will continue to increase infinitely, but it's going to take a while to get there. So connecting those points, we can kind of see that relationship. It curves up at first and then starts to curve flatter and flatter as we go further. Again, it won't ever flatten out completely because these numbers, these y values, are going to continue to increase, but it's going to take bigger and bigger changes in x in order to make that happen.